Okay, now for the second video. So this second one is called the product rule, and the way we use a product rule, or when we use a product rule, is when we have two functions multiplying together. So for instance, if we had y equals x squared sin x, then you'd have two separate functions that are multiplying together. And if two functions are multiplying together, you can't differentiate. So what you need to do is you need to split them up into two functions. Another example could be y equals 4x cubed log x. So we've got our first function here, and here we've got our second function. But either way, we've got to come up with a way of differentiating those, and the way we do that is we use something called the product rule. The reason that's called the product rule is because it's a product of two functions. And what it is if we have y equals uv, well, u is the first function and v is the second function, then we can say that dy by dx equals u dv by dx plus v du by dx. Now it looks a lot more complicated than it actually is. And so what we'll do is we'll go through an example just to show how to do that. So here we've got two functions. We've got x squared as our first function, and we've got this one here as our second function. So we're going to let u equal x squared, and we're going to let v equal 3x minus 1, or square root of 3x minus 1, which we're going to write the power of 1/2 so that we can actually differentiate it. So if u is x squared, then du by dx equals 2x. And the second one, v, if v is that there, then dv by dx equals 1/2 times 3x minus 1 to the power of minus 1/2. But once we've done that, because this is the chain rule, we've got to multiply what's inside the brackets differentiated. So we're going to times that by 3, because 3x minus 1 differentiates to 3. Now if we go back to our previous screen, then the differential is u dv by dx plus v du by dx. And when we do this in class, because we're going to come across this so many times, we're going to have loads of examples of this. We usually write u dv plus v du, unless of course we're in an exam, but we write it out as it is here. So u dv plus v du. So u is x squared. So if we do, dy by dx equals u dv plus v du, then u is x squared, so that's going to equal x squared times dv by dx, which in this case is 1/2 3x minus 1 power of minus 1/2, then multiplied by 3, plus v du, where v is 3x minus 1 power of 1/2 times by du, which is 2x. And there we go, there we've done it. However, leaving it like that would be rather messy, and we know that we're going to lose marks if we don't tidy it up and factorise and do all that sort of stuff with it. So let's have a look at the first one here. We can write this as, we can bring the 3, use different colour, 3, the x squared and the 1/2, and we can write that as 3x squared over 2. And because this is the power of minus 1/2, what we can do is we can extend this and put it on the bottom. So I have the square root of 3x minus 1 plus 2x bracket 3x minus 1 all square rooted. That looks a little bit neater, but as we've done in a lot of C1, C2 and C3 is if we've got two fractions that are adding together, what we tend to do is we add them together. So we've got 3x squared over 2 square root 3x minus 1 here, and we've got this one here. So what we're going to do is we're going to make sure, if we're going to add the two fractions together, we've got to have a common denominator. So we are going to put 2 lots of 3x minus 1 as a denominator, but we're also going to multiply the top here by 3x minus 1 all square rooted. So 2 lots of 3x minus 1 square rooted. So doing that, we end up with the first fraction doesn't change, 3x over 2 lots of 3x minus 1 square rooted plus, now the bottom is 2 lots of 3x minus 1 square rooted, but the top, if we multiply this by this, the 2x times the 2 gives us 4, or 4x. The square root of 3x minus 1 times the square root of 3x minus 1 equals 3x minus 1. So then we're going to multiply out the brackets on this side, so we get 3x squared plus, if we put it all over, because the denominator is the same now, 3x minus 1. So if we multiply the brackets, we get 12x squared minus 4x. They're going to go together, so we get 15x squared minus 4x all over 2 lots of the square root of 3x minus 1. And if we simplify by factorising out the x on the numerator, we get x bracket 15x minus 4 all over 2 lots of the square root of 3x minus 1. And that would be as simple as we can make it. Now, the good news is that if we get to this stage here, we get 3 out of 4 marks. For simplifying and tidying it all up and then getting all the way down to this point here gives us the last mark. So we've got 3 marks for this bit here, and this bit that's crucial, and then the tidying up bit is worth an extra mark. So don't beat yourself up if you struggled getting down to the last part. It's really the first part that we've really got to look at. So if we have a look at one question, and this one will be a little bit easier. So the one I'd like, actually, in fact, no, we're going to go through it together. So the question is to differentiate x cubed bracket 2x plus 6. Now, the good thing is, if I'm talking too fast, you can, of course, pause the video, go back, because all these are going to be your notes. So let's differentiate this. The first thing we notice is it's 2 things multiplying together. We've got the x cubed here, and we've got the 2x plus 6 all to the power of 4 here. So we're going to call this u and this v. So the next thing to do is find out what du equals and find out what dv equals. So du is going to be 3x squared, and dv, again using the chain rule, 4 lots of 2x plus 6 power of 3 multiplied by what's inside the brackets differentiated, which in this case is just 2. We then use u dv plus v du, of course putting the dx there as well. I know I'm very lazy and I often neglect to do that. So u times dv is going to be x cubed times by this thing here. So 4 times the 2, so 4 times the 2 times the x cubed gives us 8x cubed, and that's multiplied by 2x plus 6 power 3 plus v du. So we've got v and we've got du. So that's times 3x squared bracket 2x plus 6 to the power of 4. Now this one's a lot easier to tidy up, and a lot of the exam questions are like this. So we can then factorise out of this expression. We can factorise out an x squared. We can factorise out a 2x plus 6 cubed, because we've got a cubed here and we've got it to the power of 4 here. So if we factorise out an x squared and 2x plus 6 cubed, inside the bracket you need to multiply the x squared by 8x to get the first part, and you need to multiply this by 3 lots of 2x plus 6. And that'll give us the second part over here. Then it's a matter of tidying up this bracket here, leaving us with x squared bracket 2x plus 6 cubed bracket 8x plus 6x plus 18, which then if we tie it up again, x squared bracket 2x plus 6 cubed 14x plus 18. Now sometimes they'll say show that it equals this. So what you could do in this third bracket, also in the second bracket, you can factorise out the 2. So if we bring that outside, that would be 2x squared 2x plus 6 cubed, and that's 7x plus 9. And that's it. So that's our second lesson on the product rule. Quotient rule is up next.